A great pleasure to be here, and thanks for having me. It's a great pleasure to talk to you about open collaboration. I'm a professor of strategy and innovation here at CAS. I've been working in innovation and the development of software specifically for many years. Now also involved with projects more in the strategy group on business models, and I also work on organizational regulation. It's kind of the side where we specifically focus on how regulation works when information systems are always between what I do and the rules that are being set or are being set. So to give you a bit of sense, I've been at CAS for a bit more than 3 years, and I'm Swiss originally. I've been working in Switzerland before. This is a work with 2 co-authors in the US. Albert particularly is involved directly, was as a hacker and now as a researcher in this cloud computing area. So we look at OpenStack, and we look specifically at what we call open collaboration. It's part of this wider, let's say, wider discussion about distributed innovation, open innovation, and specifically what we look at is how individuals and firms collaborate in online communities. That's the topic here, because there is a change, if you want, happening in the way open source and open communities and open hardware is proliferating. You might be involved in different projects yourself, from open science to open government. A lot of this openness builds on the idea that when producing something, be that software or policy or ideas in research, openness gives us the opportunity to see what others are doing, interact with what others are doing, and look at the artifact that they're producing, which helps to coordinate. In fact, with the academic guest who was cast today, Francesco Rollani from Luis, I've worked on specifically how open source communities collaborate around the artifact that is the code. So the code itself structures the collaboration. Of course, there is conversation around it, but there's a deep-seated belief, if you want, among programmers that show me the code, and then we can talk about what's next and how we collaborate. So, starting with this attempt at more insights in open collaboration and in which way open communities work with each other, we started to ask the question: is it really true that everybody just collaborates, or does it just look open, but everybody works on their own set of problems? So that was a bit the starting point for this project. And fortunately, we had a set of data that I'm going to talk about. So basically, I'm going to give a summary of a research paper with some results, but it's quite focused on this specific topic, and I'm deliberately not making statements beyond the empirics that we've studied, but I do believe that it does have implications for other communities, not only open source software communities. So what is the context? We look at a set of communities that develop software, open source software that you're probably familiar with. We're using this every day when we use, say, a phone that runs on the Android operating system, when we use the internet that uses Apache to run servers, and we use browsers that are open source, etc. Many of us who are not much into IT are not much aware of the licenses in software, but it's fundamentally important to allow anybody who's capable of reading code to actually look at the code and study how it's been written and modify it and republish it, etc. So this philosophy of open source is in a way a background and a source of inspiration also for other open collaboration communities. Now, I'm going to focus on the one on the top right side, this OpenStack. I'm going to say a little bit about this in a minute. But what I want to focus on theoretically, and what's the interesting question for this work, is that it's not always been clear that firms and individuals collaborate well. Because in the past, this is a very contested relationship. That individual users of software may like to code and contribute and give it away for free again, but they may sometimes be skeptical to give it away to companies that will then sell it or somehow make money from the software. So this relationship is not necessarily an easy one. And this is how we can think of it in a simple way, that we have basically the layer of businesses that participate in open source software development communities. Some firms are users, essentially. They need a piece of software because they run whatever business process they want to make work and use open source software, and for this need so much software that they hire programmers to help them develop these systems, adapt them, etc. And they're happy to contribute to an online community to make it open again and license it as open source. Other firms, which we label producer firms, they're directly selling a service based on this software, if not extensions to the software and customized elements of the software itself. And then we have the independent user. So if you look at the community level, firms become software engineers hired by this company, and some of the independent users are not hired by anyone. They are the typical hacker, if you want, when you think about the history of open source software and free software in particular. They're the individuals who are there for their own personal use. They want the software because they like the project or they're passionate about this piece of software. Very often also they're passionate about the type of license. So I said free software, and the movement that started open source is a movement about making technology available to others, sharing software that I've developed with somebody else in spirit of mutually helping each other, learning, building technology together. So if you want to have these three parties participating in a community, then our question is, do they solve each other's problems, or do they all do their own thing? Different predictions for this. Now, what are the problems, if you want? The nice thing in what we could observe is in this community, and that's just a bit of a preview to the data, some problems are path dependent and other problems are path creating, which means often that the path dependent problems are fixes to something that is already there but may not work quite as it should. The path creating types are new features, new things that change the path of the overall project or add a significant new piece to it. These are oftentimes a bit more significant innovations. And individuals or firms, any member of this community, posts these problems as saying, here there is a problem, something doesn't work, something sometimes called bug reports, to invite others to fix it if they don't fix it themselves immediately. The other one is the path creation type of problem, where individuals post challenges that are they're bigger. In this specific community, they call them blueprints. Sometimes they call them feature requests. It depends a bit on the community, which is saying, we really need this other functionality. This is a bigger thing to do, but we really need it. I want this to be programmed. Whoever feels up to it, please go ahead, etc. So it's the posting of a problem that is a bit more significant. Here's an example, just a screenshot. So you see, we see people posting problems, and we see other people submitting patches that are supposed to fix or address this problem. So we can look at it very granular on the level of the problem itself as it's being solved. What does the literature tell us? So there's some work on the contributions. This is our basic research question, which is the title. So we're asking, who is really solving whose problem? There's some insights into this, both on the level of the technology and on the level of how does the collaboration work. But there isn't that much, because usually people assume, researchers have assumed that there is some cross-collaboration going on, but there's not much in detail. So we're asking a bit more in detail, how has this been explained? I said first, there's evidence for conflict. There's work that demonstrated that individuals hesitated to stay in the community and make contributions when they saw that a company dominates the community, and this appears too powerful. There is recent work on what the authors call open superposition. And it's a very interesting observation, specifically in open collaboration, which is motivationally independent layers of work. There's different people contribute pieces of technology for different reasons, and how does it work that a community actually makes these converge into a functioning product? And they document in detail the mechanisms on the level of the technology where this superposition is building on somebody else's work, but in a somewhat opportunistic way, that they showed that sometimes people waited to make a contribution because they saw, this works for the moment, but I need this other, whoever did this other piece to do, get one more step further, and then I can integrate it and solve a bigger problem. So there's a lot of fine-grained and interesting technology layers to be studied in how this collaboration works. So on the level of code, we have some insights in theory. We also know for a long time that self-selection into tasks is how these communities work. People are not, in many cases, the independent contributors for sure are not mandated to work on a specific problem. They pick the problems themselves. The engineers that are hired by firms, obviously, they're more directed, and there may be some internal policy that tell them you need to work on this and that. But still, they pick problems to a large extent. And we figured, this is with Francesca Rulani, who I mentioned before, we looked at the social practice that informs the collective work in terms of values and directions and also ideas of quality. That means that the way in which software is being developed in open source generally, but also in specific projects more specifically, is that people have an understanding of what is the good and right way to build this software through the tradition of the specific project, if it's been around for a long time, but also in general through these values that are part of the open source universe, or the bigger free software community, if you want. And these values help give people a sense of what is important next, and how do we look at the code, what is a good way to code. In detail, this can look like things like how to document code, how to improve code to become more modular, etc. So there's some ways that collaboration has been studied in this open context, and again, not to the extent of individuals. Thank you. So what we did, another theory piece, I will not go too deep into this, we look at path dependency. There's work on how organizations converge if they manage to build a project, that they build on each other's work and extend a path that is already there with different motivations why people create a path and continue on that path. These are four elements that come out of theory. One of them simply because it makes sense to coordinate what we're doing, not to replicate everything. Others, learning. I'm learning when I'm building on somebody else's work, and I learn what's already there, etc. So this leads us to hypothesize that some of the shared problem solving comes from specific motivations of why it makes sense to build on each other's work and not replicate everything, and not to parallel, and actually to meaningfully learn from what others have done. So this leads us to see, well, yes, some arguments point to the fact that these actors only solve their own problems, and others lead us to suspect, no, maybe we have reason to believe they do solve each other's problems to some extent. Again, I said we looked at OpenStack. We have a number of independent users here characterized as these individual figures, and we looked at who are the other contributors. Are they working for firm users who are using this cloud computing, such as the university or other companies, and which are the firm producers who are actively building this software in order to sell services based on it. So they're benefiting from the sale directly or indirectly, if you want, depending on what the license permits. But obviously, there are many ways in which firms can benefit directly in their business from building an open source software. This specific community has the great advantage that they label problems. That you need to say, is this a bug fix, or is this what they call a blueprint? Is this a feature request, a path creating type of problem, which is a wonderful situation for us to study these two problems. So we had from about 7,400 proposed features, because they were not clearly classified, we lost over 2,000, but we still have 5,000 problems that we can look at in detail who solved them over a 2-year period. We see hundreds of contributions by the different actors. I'm not going to spend too much time on the empirics, also because it's Albert's work, and if you ask me a too detailed question, I'll have to check with Albert. It's the beauty of co-authorship. Also, I'm not going to read out the hypothesis, but jump to to the results. So when we look at a similar table, we try to see what does the analysis tell us. First of all, yes, there is a lot of own problem solving going on, and you see that with the wherever you see the this is the actors revealing the problem, and these are the actors solving their problems. And we see a lot of high collaboration on their own, where the actors are the solver and the user is their own. But we see a lot of high collaboration also across the different actors. And this is the interesting part that partly confirms what we suspected, that people do learn from each other's problems and solve other actors' problems. And more in prose, first, yes, a lot of own problem solving, some unexpected results. There is, so the path creation problems are the new feature requests, the more radical type of innovation. And there we see collaboration, which seems to be because users who generate a problem and they request a feature that is important to them, they create attention around it, and they create attention also among other developers that are not independent users to help them solve their problem and build a new feature that they've requested. So we see company engineers work on problems and feature requests by independent users. Conversely, we also see that the independent users collaborate with firm users, but less so with firm producers. This gives a bit of nuance to the earlier conflict, that if the firm producers are really in it for the business, they get less contributions than the firms who are in it for the use of the software. So the firm users, they get problem solving and collaboration from independent users more than the firms that are in it directly for their business. So that's one finding where we could substantiate this a little bit. I think I'm about to run out of time. Some theoretical implications, but I'd rather ask you for questions.
Thank you.
Thank you very much.